recording. Now, good news, guys, when I'm recording, I'm only recording down on the paper. You'll never be on camera. I don't want to do that to you guys. All I'm doing is recording what we talked about in class and the work that we did in class. Okay? If it's a situation for me, let me know, and I can choose other classes to record. It's not a big deal. That's good. Well, we talked about accuracy, and we were talking about how close a measured value or result is to the true or accepted value. If you are needing writing utensils, I have a box up front here, metal box. It looks like a old straw dispenser. It's got a bunch of pencils in it. You're welcome to take pencils if you need it. I fill it up on a regular basis. It's there for you guys. But how close a measured value or result is to a true accepted value. So if my true value is on my target, a bullseye means I'm accurate. Spot up here means I'm not accurate. If my target is 9.8 meters per second squared, a test result that gives me 9.8 meters per second squared is accurate. If I get something like 6.7, haha, we're not letting the meme die. This would be not accurate. So be mindful of what you're looking at. Accuracy is, do I hit the target or not? If this is my target, my bullseye target, dead center is where I want to be. If I'm looking for a measurement, getting the exact same value means I'm accurate. Getting something that's off of it means I'm not. Now, if you're curious, you can also be writing this on the back of your sheet. You flip the paper over, got a whole bunch of blank white paper on there. I like to spread my writing out a little bit so you guys can see a little bit better. That's why I have a blank sheet of paper. If you like to use a blank sheet of paper too, like I said, they're over there next to Adam. Feel free to go grab yourself one or two. You're not hurting my feelings. Do we feel comfortable with the definition of accuracy? Okay, got some head nods in the back. That's awesome. Another concept we talked about was precision. Now, if I ask for the definition of precision, I'm looking for two main things. I'm looking for one of two things. I'm looking that you're telling me it's consistent and or repeatable. Those are the two. If I ask for like a one-word definition for precision, consistent or repeatable. This talks about how close multiple measurements or attempts are to each other. So I'm looking for consistent, or I'm looking for repeatable. Multiple attempts are consistent with each other. So I go back to my target. And I had one where all my arrows hit the same area. Though I may not be accurate, I am consistent with where I hit. That's my precision. If my target is 9.8 meters per second squared still, and I see my values 10.0, 10.1, 9.9, they're right next to each other. This would be an example of being precise. If I was 10.0, 6.7, 4.2, I am not precise. They're too far apart from each other. Precision is they're landing right next to each other, if they're not landing on top of each other. Not being precise, I'm going all over the place. Heck, one of my targets could even be 9.8. I was accurate, but I wasn't precise. Does that make sense? All right. Let's put a little bit of it to the test. So I'm gonna push this paper up real fast, and I'm gonna grab our worksheet here. So for the first part, we're going to be trying to determine if something is accuracy, precise, both, or neither. A measurement was taken 3 times. The correct measurement was 68.1 milliliters. That's my target. Circle whether the set of measurements was accurate, precise, both, or neither. On your whiteboard, I want you to write your answer for A. I have 78.1 milliliters, 43.9 milliliters, 2 milliliters. If it's accurate only, I want you to write an A. If it's precise only, I want you to write a P. If it's both accurate and precise, you'll write a B, or if it's neither, you're going to write an N. I want you to think about it, and I want you to choose A, C, B, or N. I want you to write that on your whiteboard. Now, has everyone chosen an answer? Yeah. All right. I want you now to turn to your shoulder partner on your right. Now, Adam, you're going to be in a little bit of a situation we're going to figure out in a quick second. You and your shoulder partner are going to show each other your answers, and you're going to determine if you're going to determine was the other person right or wrong. If both people are right, if both people come to the same answer, perfect. I want you guys to stand up together. You both have the same answer. But let's say that Andre, you're going to turn to Allison. Well, Catherine's going to go to Blanca. Diego, right? Armando, you're going to talk to Andre. Allison's going to talk to Allison. Adam's going to talk to Daniel. Boom, 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 boom. 2, 4, 6. I'm going to talk to Jackie. Getting these all ready. I'm going to talk to Jackie. We're going to see if we have the same answer. So turn to the person to your right. See if you guys came to the same answer. If you both give the same answer, stand up. If not, or consensus. All right. Waiting for everybody to stand up. That's my cue to let me know everyone's got their answer. All right, gang. Do me a favor. Take your whiteboard, flip it around. Let me see what you got. Look at you guys. Ah, beautiful. It is neither. They are neither. Great job, guys. Great job. So let's try B. Remember, my target, the correct measurement, 68.1 milliliters. If I go to B, 68.1, 68.2, 68.0 milliliters. I want you to circle which one you think is the right answer. Is it accurate? Is it accurate only? Is it precise only? Is it both or is it neither? For B. Once you circle it, I want you to write it on your whiteboard so you can show me. Did you put A, P, B, or N? That's what I want to see. Has everyone had a chance to come up with an answer? If I'm going too fast, let me know. I'll slow it down a bit. So I want to give you guys a little bit of work time because today the homework was just finishing off this paper. There's these 4 questions I'm asking you, and there's 5% error questions I'm going to ask you. We're going to work one of the percent error questions together. You're going to finish the other 4. Much like how we're doing 2 of the accuracy only, precision only, both or neither. We're going to do 2 of those together. You're going to do the other 2 by yourself. So 68.2, 68.1, 68.0. Accurate, precise, both, neither. Show me what you wrote. All right. We got pretty good consensus on this one. All right. Let's take a look at it. Does any of my 3 trials hit my target?
Yes.
Yes. So it's definitely accurate. For sure, we know it's definitely accurate. But I need to see how close those numbers are to each other. 68.2, 68.1, 68.0. Are those numbers close to each other?
Yeah.
Absolutely. So it means they're both accurate, they're both precise. That means that they are both. Everybody see how we did that? You're going to knock out the other 2 on your time, but before we get into that, I want to make sure that we also talk about percent error. So you definitely want to write down this equation that we're going to talk about. Percent error is a calculation done in many branches of science. Science labs, I apologize, I was burping there. To measure how close an experimental value is to the accepted value. Sorry, pushed up too far. There we go. I apologize about that one, guys. So that's our definition for what percent error is. It's a calculation done in science lab to measure how close an experimental value is to an accepted value. So when we were looking at, I'll give you guys a chance. Let me give you guys a chance to finish writing stuff down before I move stuff around on you. Let me give you a second. Sometimes I get a little too fast for myself. Okay, so let's write down what that equation is. It's a real simple equation. You have percent error is equal to, we're going to take the measured value and subtract that from the actual value. We're starting this off. I'm going to take what I measured in my class or in my lab, subtract that by what the actual answer is. I'm going to then divide that by the actual value. My last step, I'm then going to multiply this fraction by 100%. So I take what I measured in the classroom, subtracted it from the actual value. I'm going to divide that difference by the actual value, and I'm going to multiply that by 100%. Now, some of you guys might be going, man, Mr. Wiseman, I'm over my head right now. You're exactly where you need to be. I have a quick question for you. Anything that you ever did, were you the best at it the first time you did it? No. A lot of us have the ability to run, yes? Feel pretty confident we can do it. And if nothing else, we can get into a nice jog, right? What did I have to be able to do before I could jog or run?
Walk.
I had to be able to walk. What did I do before I could walk? Crawl. If you are uncertain where you're at right now, you're just at the crawling stage. You're not supposed to be at the top of your game day one into chemistry. Don't beat yourself up for something for unsure about an equation. Part of my job is to help make sure you feel comfortable with it. We crawl so we can walk. We walk so we can run. I will never expect to give you something and then you are running by the next time I see you. We're going to crawl together. We're going to walk together. We're going to run together. Let's put it into practice. So this is my equation. I'm going to use this equation for all next 5 questions. There's one on the back, just be on the safe side. Put that right there. Perfect. Looking at question number 1. A student measured a string as 1.25 meters long. I'm going to circle the numbers because these are things I'm looking for in the question. What do I need from the question to answer the question? That's why I'm circling it. So I definitely know I need 1.25 meters. Or else why would they give me a number? The teacher said it's actually 2.12 meters long. What is the student's percent error? So I need to identify the measured value and the actual value. Which one do we think is the actual value? The 1.25 meters or the 2.12 meters? 2.12 meters, right? Because it right there was actually. I could use my question to help me out here. 2.12 meters. I look at my question, measured the string at 1.25 meters. Use the question to help you answer your question. So now I'm just going to grab my percent error equation. 1.25 meters minus, don't forget the m, because that's my unit. We want to make sure we're bringing our units with us. 2.12 meters Divide that by, is it 1.25 I'm dividing by, or 2.12? What's going to be in my denominator?
1.35 meters.
Not the 1.25, that's my measured, right? It's going to be the 2.12 meters because that's my actual, right? That's all right. Hey, I appreciate you putting yourself out there. And then we'll multiply that number by 100%. Now, the cool thing about these, everyone should have one of these calculators here, TI-83 calculators, is that I can make it do a bunch of different things for me. And I'm going to show you an easy way to answer this question. So I got to think back to my days in algebra. Am I going to do the parentheses first, divide first, or multiply first? What's the first thing I want to do? Parentheses. We're back to PEMDAS, right? PEMDAS never goes away. P is parentheses. We always start with P. So I have 1.25 minus 2.12. I hit enter. I'm given a value. You want a calculator? They're in the little caddies. If your calculator is not working, let me know. There could be a fact that it could be a situation where the batteries are just dead. So that I have one or two extra ones laying about that I can just swap you out on the fly real quick. Okay. Oh, no, okay. Oh, maybe the batteries are low. They just won't push it all the way, that's all. But I'll hold on to this one. That one looks better. Alright. So we get a value, right? Now, do I really have to retype every value that my calculator gives me? Not with these. What's the next step? Do I want to divide by the 2.2 or multiply by 100%? I want to divide. So I go and I'm going to hit the function divide. What my calculator does is it takes whatever value I had here and pulls it down to my next question, my next function, right? So I just hit divide. So it's taking that answer, putting it here, and I'm dividing that 0.87 by 2.12, enter. Now that's a super long number. I don't want to have to type this in every time. Guess what? I don't have to. I just have to press what's the next function. So I took care of my parentheses. I divide by 1.12. What's my last step? Multiply by 100. Multiply 100. When I'm recording percentages, am I going to record all of this number here? Typically, when I'm recording percentages, I'm going to stop at the decimal. For today's homework, I want you to stop at the decimal place. The student was 41% off of the target. Yes, there's a negative. When we're dealing with percent errors, we ignore negatives. Just a heads up, you're just going to record that as 41%. Technically, we can do the absolute bars in between for the measured value minus the accurate value. So that's why there's no negative numbers that pop up. But some people get confused on that. That's why we just put it around in parentheses. Same concept. It just means that there's no zeros are available and no negative numbers can happen. So if you already got a head start and you already took care, C, D, all you got to do is wrap up 2, 3, 4, 5 on the back. All I need you to do is come in with these answers. You could be completely wrong. That's quite all right. When I see you on Friday, while you guys are working on your warm-up, I'm going to come around and check off whether or not you got the homework done. I just want to see in a text. You got all of them wrong, that's okay. I want to see the attempt though. If you got every question wrong, but you made an attempt, you get all points. Hard work crawling is the homework. I don't penalize you guys for not knowing how to do something without me standing over your shoulder. The goal is that you made an attempt. If you could, put the calculators back in the caddies, the whiteboard, stack them up, and the markers back in the caddies. We clean it up so that the next group of people come in here, they got a clean place to work. Okay. Like I said, if you need a 30 binder, you can't get one. Talk to me and say, hey, I can't get one. If I got some, you got it. If I don't, we'll try to find something to work. But our clock is finally kind of fixed. Wrap up those questions. We meet back here. We do a lab next time where we're actually going to be doing some measurements with stuff. We're going to do some percent error stuff, and then we're going to talk about density. That's our goal for Friday. Thank you guys for being here. I really appreciate it.